Good afternoon. Testing 1, 2, 3. Good afternoon. It's my pleasure to see such a large crowd here today. I appreciate it. And later on, we'll figure out all the bribes that were given to students to be here. So thank you very much. But it's a pleasure really today to celebrate the long-standing and positive relationship between Washington State University and Schweitzer Engineering Labs. As we talk about our drive to 25 and our goal to be recognized as one of the top 25 public research university, key partnerships with places like SEL are going to be part of the way that we achieve that really stretch goal. Ed Schweitzer and his wife Beatrice, as well as the employee owners of Schweitzer Engineering Laboratories, have cumulatively made gifts totaling more than $3.7 million to benefit WSU students, faculty, research, and outreach at nearly every WSU campus and college system-wide for more than 3 decades. Some of the highlights of the giving include $1.5 million to create the Edward O. Schweitzer III Chair in Power Apparatus and Systems, which will allow us to further accelerate our growth in our School of Electrical Engineering and Computer Science. A generous leadership gift to the Dr. Elson Floyd Medical Education Founders Fund to support the creation of WSU's School of Medicine. Significant scholarship support in the name of former WSU professors Clifford Mosher and Al Fleshig, and a street entrance into SEL was named Mosher Drive as a tribute to Dr. Schweitzer's WSU's academic advisor. Multi-year support of STEM summer research activities on our Tri-Cities campus. Multi-year support of First LEGO League and Robotics League as part of Connor's 4-H Science and Robotics. State-of-the-art lab equipment at WSU campuses across the state. And I could go on and on about all the different things that have happened to make our educational experience at WSU better than it would be without our partnership. Since the SEL's earliest days, WSU and SEL have collaborated closely, supporting each other, developing state-of-the-art power grid technologies for the country, and training next-generation power industry leaders together. SEL's employees have collaborated with WSU faculty in over $1.2 million in research projects involving multiple patents. They've also provided guidance on our advisory boards, host on-campus information sessions, conduct resume reviews, lead classroom lectures, collaborate on research projects, sit on intern panel discussions, conduct student tours of SEL, and sponsor tables at student club events. 82 WSU students representing a variety of colleges and fields of study are now participating in internships at SEL. Thanks to all these engagements with SEL and its talented employees, WSU students are better prepared when they graduate to enter the workforce. In the past 2 years alone, SEL has hired more than 10% of our EECS graduates, more than any other company. Today, we have more than 200 alumni that work at SEL. So a big round of applause about the relationship that we've had with SEL. So I really have the pleasure of introducing our speaker today, Dr. Edward O. Schweitzer. Ed is recognized as a pioneer in digital protection and holds the grade of Fellow in the Institute of Electrical and Electronics Engineers, a title bestowed on less than 1% of IEEE members. In 2002, Ed was elected as a member of the National Academy of Engineering. Dr. Schweitzer received the 2012 Medal in Power Engineering, the highest award given by IEEE for leadership in revolutionizing the performance of electrical power systems with computer-based protection and control equipment. Dr. Schweitzer is a recipient of the Regents Distinguished Alumnus Award and Graduate Alumni Achievement Award from Washington State University and the Purdue University Outstanding Electrical and Computer Engineering Award. He has also been awarded several honorary degrees from both the University Autónoma de Nuevo León in Monterrey, Mexico, and the University Autónoma de San Luis Potosí in San Luis Potosi, Mexico, for his contributions to the development of electric power systems worldwide. He's written dozens of technical papers about digital relay design and reliability, holds nearly 200 patents worldwide pertaining to electric power system protection, metering, monitoring, and control. Dr. Schweitzer received his bachelor's and master's degrees in electrical engineering from Purdue University and his doctorate from Washington State University. He was a member of the faculty at WSU and Ohio University before starting his business, Schweitzer Engineering Laboratories, in the basement of his Pullman home. In 1982, he left the university to devote his efforts full-time to growing the Pullman-based company to a leading designer and manufacturer of digital protective relays for monitoring and control of electric power systems. Nearly every utility in North America uses SEL products, which can also be found in industrial and commercial power applications in 157 countries. SEL is also one of the region's largest employers with more than 5,100 employees worldwide. When you think about businesses and growing a business from the basement to 5,100 employees, we think a lot of times that that can happen in the Bay Area of San Francisco and Austin, Texas, in the Seattle area. But to do that is a tremendous accomplishment. But to do that in the Palouse, in a small community, when I'm sure you had lots and lots of people over time to say, hey, if you're going to be successful, you need to not be in a small community. But to build that here and to provide jobs for so many people in our region and community, I think is a real testament to Ed. So entrepreneur, inventor, businessman, philanthropist. Ladies and gentlemen, it's my pleasure to introduce you to the President, Chair of the Board, and Chief Technical Officer for Schweitzer Engineering Laboratories, Dr. Ed Schweitzer.
Well, good afternoon. Thank you for being here, and thank you, Kirk, for a very kind, generous, and introduction. It was a little long because I'm old, so there's more things that he felt obliged to tell you. One of the reasons that it's so easy to make a business in Pullman, Washington is, well, we live a half a mile away from where we work. So if we were in the Bay Area somewhere, we'd spend all our time driving instead of working and thinking. Something to think about. And who cares how many cylinders your car has when you live only half a mile from work? Something to think about. So you students that are going to school here at one of the great land-grant universities in the United States have not only a great opportunity to get a fabulous education at a fair price here at Washington State University, but also the opportunities before you to invent your future. So I want to talk a little bit about fostering free enterprise and inventing the future, your future. So what is it that we do anyway? We invent, design, build, manufacture, support the systems that control and protect electric power systems around the world. So you may have noticed that every now and then a thunderstorm will come through the area, or a windstorm. You see the lights blink off and then come back on. Yes? No? Yes. Okay. Hopefully they come back on. So most faults are temporary, and it's protective relays like we make here in Pullman, Washington, 99163, that trip the breakers. They're the brains, and then automatically reclose the breakers to get the lights back on as quickly as possible. And these are the folks, your friends, neighbors, colleagues, students, professors who have worked together to make that come true. So we're not only part of the electric power industry, but Washington State University, thank you, Kirk, is a customer. We have our metering systems in many buildings here, hydroelectric facilities, power plants of all kinds, petrochemical industry, transportation, pharma, and no matter how you make or use electricity with photovoltaics or wind, or even that four-letter word coal, that SEL equipment is there making it safer, more reliable, and more economical. We're also involved in our equipment is in industries related to manufacturing, such as food processing and metals and mining, for example. And finally, the last little vignette on the slide there is a picture of a padlock, reminding me to mention the big role that we play in cybersecurity today. So in this day and age, you can't pick up the paper without reading about fair trade and tariffs and quotas and things that are throwing the sand in the gears of free enterprise. Now, economic freedom and political freedom are inseparable. How do I know that? Because Milton Friedman said so. So you can take that to the bank, okay? So it is really the economic and political freedom that you and I enjoy that are inseparable and that give us the opportunity that no other country enjoys to the extent that we do here in the United States of America. So it's so important to defend fair, free, flat, open markets and ask ourselves questions like, if somebody comes up with an idea that the government needs to do something, is to ask ourselves, is this really an issue of state? And the test is really the Constitution, going back to first principles, something universities are best at doing. So I implore you as students and you as professors and leaders in academia to ensure that Washington State University focus on fundamentals. Harriet Regas used to be my boss when I taught electrical engineering here. And one day she got all excited about fundamentals for electrical engineering during a staff meeting. And she said, we need those guys in the physics department to teach our engineers that F equals ma and you can't push on a rope. So that was just the starting point. That was not all she expected you guys to learn in physics, okay? You ain't getting off that easy, okay? So, but the idea is that we have to go back to first principles. And when you do, when you take that step back, not so far you fall off the back of the stage, but when you take a step back and think about the why, how something really works, how a customer is really going to benefit, you're going to get a lot better answer. You'll probably create something new, which stems from the psychological self. And it's a very fulfilling part. My friends in the psychology industry have taught me over the years. So our approach in business is organic growth. I remind myself and our peers in our company that our middle name is engineering. It's not Schweitzer Engineering Laboratories. It's not acquisition laboratories or purchasing laboratories. It's engineering laboratories. And so we grow by inventing new products, developing or entering into new industries, serving new sectors of the economy, building larger projects, expanding manufacturing, and integrating vertically, which means we're making more and more of the things that we use. On the bottom here is a key phrase that has been attributed to several different people, including Abraham Lincoln. The best way to predict the future is to invent it. That's so important. It's on the floor when you walk into the Zockel engineering building at SEL. The best way to predict the future is to invent it. You ain't going to get to predict the future by, reading economic reports or financial statements. That is all like driving. That looks like driving, looking in your rear view mirror. But the future is what you and I and we invent. And what a great way to do it. For us, it is just such a blessing and a privilege to be not only half a mile from work, but half a mile away from Washington State University. Our business is based on values. I like to say that we try to run our business the way our mothers would want us to. There's no difference between ethics and business ethics, as we teach our employees when they join the company and remind ourselves frequently. Ethics are ethics. And when you start thinking about that, instead of a business transaction being trying to grab some market share, instead it becomes, hey, let's grow the pie. There's something for everybody to do when we do that. So these are the 9 values that we spell out, and we brought some literature in the back if you want to read some more of those. Our purpose is in the green words on the bottom: to make electric power safer, more reliable, more economical. That's our roots. And we have branched out into cybersecurity and some areas of communications. But every time these areas that we get into, they stem from this root purpose. We're growing. We are 100% employee-owned. The ownership is S Corp ESOP. It's fabulous. And you know what? It's just like the difference between renting an apartment and owning a house. Because if you work at SEL, you're not renting a job, you're owning part of the company. Isn't that cool? And you're creating the future in electric power in other areas and doing it as a part of the community. And frankly, as a part of the community of your alma mater. Here's some more numbers. Kirk gave you a few. We like to say, in God we trust, all others bring data. There are 319 SEL folks currently working for us who graduated from Washington State University, including myself. And we are in virtually in every aspect of the business. Business itself, human resources, R&D, Marcom, manufacturing, engineering services, sales, customer service. We have 82 SEL interns, 1/3 of our intern force. So we have about 240 interns right now. 1/3 of our interns attend Washington State University. We love having a lot of interns, a big, vibrant intern program. Why? Well, it's a good time it's a great opportunity for young people. It's a good tie to the university. It gives us essentially it's like a 1-year job interview, isn't it? And a friend of mine who's, his name is Scott Ernest, he's the CEO of Textron Aviation. We were comparing intern programs one day, and Scott told me something that I'll never forget. And he said, Ed, I consider it a quality escape of our human resources department if we have to go to the employment market instead of promoting an intern. What do you think about that? Now, I know that's strictly forbidden in academia. If a student gets a PhD here, then, well, he or she has to leave in order to be a professor somewhere. But at least for a couple of years. I did that. I got mine here, went away, and then came back, and so glad I did. But it's a beautiful thing to be able to have a continuous process. Moms and dads send their smartest kids to go to school at Washington State University. And what a great opportunity it is for our community, for our university, our community writ large, for SEL, when young folks while they're studying, get involved as interns, complete their studies, and continue, and do so as employee owners of a company whose influence is in over 150 countries today, making electric power safer, more reliable, more economical. This works because 3/4 of the interns become full-time employees. And I'm thinking that the other quarter, they're going to come back once they try something else. Another cool thing is that pretty much anything that you imagine you can do. In fact, look at it the other way around. If you don't have a dream, those dreams are never going to come true. And I hope the people whose names I put on this slide here agree. I didn't ask them if I could put their names on there. But Jenny Hitch, whose dad was my advisor for PhD and colleague later on, Al Flexick, that he was a wonderful professor, and he made sure that Jenny became an engineer, a geoengineer, and she's a lead editor in our research and development group. And Carissa Schlosser, who has a degree in business management, who runs our child care operations. Jake Schlosser, her husband, they met, fell in love, got married. So that happens too. Isn't that nice? Yeah, what's wrong with a little love story? Okay. Kind of funny coming from an engineer, I know, but okay. And so Jake's degree is in HR and business administration. Look what he's doing. He's a director of manufacturing. He got really interested in something that he never thought he'd be interested in. And we see this happen over and over with people. Folks who graduate from high school have little or no interest in school, get interested in making things. And pretty soon they're taking a course with us, and pretty soon after that they're enrolled in college. And many people who start out in manufacturing get the bug. Some little spark happens, a beautiful spark. And pretty soon they're graduates from Washington State University. And Jessie Hall, she graduated here in mechanical engineering, and there's one case where an engineer is doing engineering. But you look at how many different evolutions that these folks' careers have taken, and it's a kind of a magical thing, and just goes to show when people get a good, solid education, focused on the fundamentals and values, that, it's really up to them and their creativity to seize the opportunities before us all. Now, I just thought this was the cutest doggone thing, and Gretchen designed this. This is a onesie, and on the front it has a pocket printed there. It's not a real pocket, and because it's for an infant, you know. Actually, you shouldn't give an engineer anything sharper than a crayon anyway, but so those are just painted on there, see, and on the back it says future engineer and patent pending. I think that's so cute that I'll bet when we start making these that, we'll probably be making a lot of new employee owners and students for, it's pretty cute, isn't it? Okay. So where did that come from? Okay, well, we do have a child care center, and that makes a lot of sense. So thanks, Gretchen. So we opened the Zockel 2 engineering building in October last year, 2017, 100,000 square foot building. I'm just so proud of the job that we and our community did to build this here for $140 a square foot, counting the green lines in the parking lot and the desks and the basic equipment inside, not the specialized R&D equipment. $140 a foot, and it's a delightful place to work. We're real careful with employee owners' money. It's got a beautiful view from up there, looking right back. You know, it's one of these things, see, that we're looking right over here at the red brick of Washington State University. And I hope when you look out your windows over here at the university back at us that you like what you see too, because we sure feel like one big family. So if there's a Zockel 2, there must be a Zockel 1, and there is. And the idea was that people would have to walk out of one of these and up the street and into the next building. And I was starting to think, you know, that's pretty easy to do, and a few of us, like myself, probably should do that more often than I do anyway. But when the weather's inclement, you're in a hurry, it's too far. So I said, why don't we build a bridge? so we collaborate better. And there's so many, this is also metaphorical, and there's so many bridges that exist, metaphorical ones, between Washington State University and Schweitzer Engineering, in terms of the interns and the graduates and the research activities that Kirk was so kind to mention. So I had the idea, hey, we ought to build a bridge between these two buildings, a pedestrian bridge. And what came out of it at first were some sketches for real pedestrian-looking pedestrian bridges. And I said, okay, I don't want to do that. So I had this idea. I said, why don't we do something a little crazy and make it look like the structures that hold it up look like Bonneville Power Administration's 500 kV transmission towers. Why not, huh? It's funny. Okay. But, I mean, we're geeks. We can't help it. You know what they say about an engineer, you can tell the extroverted when he's looking at your shoes instead of his. See? So, in any case, I found some snapshots of the BPA towers and sent it over to our property group. And we love to say, if it's hard, let's give it to an intern, because the intern doesn't know it's hard, see? So Caitlin Smith, who's a Washington State University architecture student and an intern with us, well, her project was to come up with some good preliminary design sketches for this. And ta-da, there it is. And, well, we're going to start getting the steel on site. We've already poured the footings. And in a short time, that's what's going to look. That's kind of fun, huh? So what about some of the collaborations between Washington State University and SEL? My goodness, I'm not going to read down all this list, but it gives you an idea of the things that we're doing in terms of senior design projects, guest lectures, tours. Who's visited SEL at one time or another for something? Show me your hands, please. That's about half of us. And you're all welcome to come back and to have your first visit as well. We love showing people what we do, and we'd love to include you in that. We have scholarships and the Crimson Code Project in cyber, women in engineering, an endowed chair, many other projects on here, and some ongoing research activities. So there's just so many ways that WSU and SEL collaborate that you can't really list them all. It's more of a continuum as opposed to some bulleted list. You get past about 3 and I think bullets, and I think you would agree. So what are some of the cool new technologies that we're working on? And one of them is to speed up line protection and, for transmission and also for distribution. I'm going to show you a little bit about that. Look what the third one is, though, and that's to pursue inherently safe cyber. I like to say that today cyber is unsafe at any speed. To knock off Ralph Nader, remember he wrote that book about an early compact car, and that's what cyber is today. Our Chief Operating Officer, Dave Whitehead, and I are fond of telling people with serious faces, never connect critical infrastructure to the internet, audit this. So what is inherently, this is the idea going back to first principles, what is inherently wrong with it? So right now, so many things that you hear about cyber is more firewalls, more passwords, longer passwords, two-party authentication, and so forth. And this is like opening up a box of Band-Aids and continuing to cut yourself. So why don't we stop with the, put the sharp knife down and we won't need so many Band-Aids, see? So what is inherently wrong with it? And what does inherently safe cyber look like? And if we're really going to use cyber more effectively in terms of wide area solutions, we need to have answers to this. Now we have some that we've applied, and I'll give you a couple of examples here in a minute. But isn't that interesting that our journey in business has taken us to the need to address that question. What are the roots of cyber insecurity? Well, let's take a look now at the world's fastest line protection. This is technology that people have been dreaming about for 30 years. And we did it just right over there, about half a mile from here. This is like moving from a car to a jet. The protection is about 8 times faster. And guess what? A team of Washington State University graduates and some interns have worked on this project over the years, and we're just getting started. So you're looking at the faces of Washington State University students who graduated and put their creativity to work in moving from a car to a jet when it comes to electric power system protection. You can see our Chief Operating Officer, Dave Whitehead, who in his role as R&D VP at the time. I think it's on. There he is. See him? And he's got that tool there. It's an electrostatic discharge stun gun thing. And we're testing to make sure our devices never misoperate. Now here you are, you're trying to measure things that are moving at the speed of light and transients that we're looking at signals every microsecond, sampling 1,000,000 times a second today. And when you make a little spark, it looks something like the very signals we're trying to process. By the way, if you get stung by that stun gun, that's the equivalent of 4 cups of Starbucks, except we'll do that to you for free, and the other one costs you about $20, right? It looks like that guy over there on the left could use a shot from that thing. So let's go back to first principles and see how we're doing it. Traditional protection has, for nearly a century, has been looking at the sine waves. So that would be one sine wave, about 1/60th of a second, which would be 16 milliseconds on a 60 hertz power system. So what we've done, we make protection like that. It works great. Those are the workhorses today. Virtually every electric power utility uses SEL equipment, and we're the best at doing that in the world, and we've gotten the most out of looking at the sine waves of anybody who's practicing these arts. But watch this. What we're doing is, here's how we're moving from that one cycle car to this 1 or 2 millisecond jet. We say, wait a minute, let's look at the way the traveling waves bounce back and forth, the way they propagate along the transmission line at the speed of light. 186,000 miles a second, 11 inches a nanosecond, 6 microseconds per nautical mile, however you want to look at it. And that's all we need to do to figure out whether that's a fault that the protection should be tripping for or not. Okay, let's look at some oscillograms for real faults. This is in a 500 kilovolt series compensated transmission line in Southern California that was built, Suncrest Ocotillo is the name of the line, to bring a whole bunch of energy from a huge photovoltaic farm into the San Diego gas and electric system. And it's series compensated, which you can see here. Well, here's the pre-fault currents are all balanced. The red, green, and blue lines are all the same. And then look here, you can see there's the B phase got faulted and the current went up. But you also notice that it kind of was really big and it shrunk for a while and it got big again. And that's because it excited an eigenmode made by the series combination of inductance and a capacitor. And the proof of that is left for your homework this afternoon. So that wowing, if you will, of that eigenmode that might be on the order of 20 or 30 hertz, near system frequency of 60, is making that harder to measure. So here on this line, where you're trying to get as much of that green energy to people who in San Diego, Well, the transmission capacity is limited by how long that line was. So in go the series capacitors. And with the old protection, we actually had to slow it down a little bit so it wouldn't misoperate. Now what we do is we just zoom in and look at this stuff, the little traveling waves and the voltages and currents, and we're able to trip the breaker in 2 milliseconds. 2 milliseconds, not, here's where the protection actually tripped the breaker, the older stuff, which we also make, and again, we're the best at this, in about 16 or 17 milliseconds. Isn't that cool? It is just so much fun. It's worth getting up in the morning, you know, getting out of my Spider-Man PJs and going to work to do it. Well, it's a lot of fun for me anyway. Here's another cool thing about it, is I don't really care how long the lines are now. We're locating faults to within about 100 feet. So you imagine a 100-mile line being able to tell where a fault is to within less distance than from the front of this room to the windows back there. Isn't that cool? There's a case that just happened the other day where an overhead shield wire popped off and was dangling down like this, and pow, it was touching a phase conductor repeatedly. So this is on a, I forgot where it was. I might get it in a minute. So this thing was dangling and touching a conductor, pow. So it was that they were having repeated faults. And every time we nailed that on this very long line to it with less than 100 meters. So it's a rare kind of event that just really is the proof in the pudding. You get the same kind of a fault, and that's how accurate it is. And I'm begging to get a histogram of the events to just see for myself a little bit better than just the word story here. Again, in God we trust, all others bring data. Here's a fault. This one's on a 400 kilovolt line in Mexico. And you see what we do here is maybe you've seen these Bewley lattice diagrams. The green, these two lines that run down, the vertical ones there, the edges are represent the ends of the line. And when a fault occurs, the traveling waves propagate and bounce back and forth. And Professor Bewley came up with this about 100 years ago. And here's how you draw out the picture for that. And I was just delighted to see that Kirk and Noel were wearing the tie and the scarf with that design on, and some other WSU leadership as well. And that was good. I chose to wear a crimson and gray tie well, that's what I found in my closet. And well, of course I knew. And then here we go. Look how accurate. The utility said it's 135 kilometers out. We said 135.02. So not only are we able to trip fast, we're able to see how things reflect. Software automatically draws these pictures within a short time after the event occurs. And you can even see landmarks along the transmission line. Our friends in Turkey think these relays are the best thing since sliced bread. They installed, in fact, they were our very first customer. Turkey was first, Vietnam was second. Isn't that cool? It just excites me that from here, right here in Pullman, Washington, that we can be serving the interests of countries all over the world. So what happened here? One substation is Affion, the other one is at Tamelli. There was a fault along the line somewhere here in the middle, and we're showing operating times here on the order of a millisecond. Oops, this one was 4.5 milliseconds, but they found out that they had set their little adjustment, that they had typed in the wrong number, and we reran the case. And so here we're able to be tripping the breaker in a millisecond. In Turkey. Here's a case at a utility in India. You're starting to get the hang of this now, right? So here's a load current, and then, wow, a pretty hefty fault current. Very, very symmetrical looking. The voltages are ringing like crazy. And here is a French relay. They're a competitor of ours, Alstom, and their stuff operated in about 17 milliseconds, and ours operated in about 1.5. Ha! Isn't this fun? Now here's another cool thing. Let's go back to that Suncrest Ocotillo line in Southern California, 500 kV. We got this fault, and at a low sampling rate of 2,000 samples per second, this is about all that you see. Now watch if we speed the sampling up to 10,000 samples a second. You say, that's a little bit more interesting. And now we're going to go up to a megahertz or 100 times faster. Hold on to your hat. Wow. And boy, did that, I see Bob Olson, you're paying attention, huh? It's pretty interesting, isn't it? It's worth getting up in the morning for, as I said. Look at this. What do you think, Bob? Look at the saturation here, that the voltage went off the charts. The voltage went off the charts when this fault happened to about 3 per unit, 4 per unit. And we're surprised by it. We don't understand it, neither do they. It's a mystery right now. We'll get to the root of it because we got data. Isn't this cool? Here's another way of looking at it. The black one is sampled at 2 kilohertz, 2 kilosamples a second. The red one at 10, and then the green stuff at 1 million samples a second. Here's another one. This is in Mexico again, 400 kV, and we're looking at current. And the current was just humming along there normal, in a normal fashion, and then these spikes started happening, and after a few cycles, it went away. There's no fault. What is this, partial breakdown somewhere? We could tell it was not in the line section covered by our new protection because we're so good at locating the faults now. Even on temporary disturbances like this, we locate. And you don't see anything at 10 kilohertz. You have to sample at a megahertz in order to see it. Is this stuff fun or what? And we don't know what caused that. Is CFE concerned? Yeah. Are they interested? Oh, yeah. Will they get to the root of it? Oh, yeah. And this is a cool part of this new technology. We're making new observations these days in just about every time there's an event. And it gives us wonderful opportunities to be asking why. Why is all that ringing at the higher frequencies? Why are we seeing these 1.3 million volt peaks on a 500 kV line just produced by a ground fault? And why were these large spikes happening? And where? And some other things of breakers restriking and poles bouncing. Why? And what does all this mean for power system, the quality of the power that you and I enjoy? What does this mean to the operating and maintenance costs that utilities and eventually we have to pay for? It's an exciting time. Here's another fun thing that all this little thing does is a current goes right through there. You snap this thing onto an overhead conductor, and there's a radio transmitter in there. This has got to be the dumbest idea. It's sort of like a doorbell, okay? Current goes through, and then the transmitter says ding dong. The receiver picks it up over here, and in only 6.4 milliseconds, you get an answer out of that receiver that can be used by the protection to speed it up. Look, Ma, no internet. Not only that, there's not even a battery in the thing. And you know what you do to set it? You take the cover off of it, there's this little dip switch, you set that. You don't need a computer to set it. Some of this stuff is blasphemy in this day and age, I know. So what are they for? Well, here's a recloser, and here's a feeder, and those little backwards-looking S's, that's a symbol for an electrical fuse. Now, fuses take time to interrupt when faults happen. So what you want to do, especially if your house is out here at the end of that feeder, okay, and there's a fault on that feeder, you're going to wait for that fuse to blow. But the fault's over here on my feeder, you don't want the recloser back here closer to the source to trip, because that would interrupt you, and that fuse, you get the idea. We want to be selective. So you can put these fault transmitters out there that help the protection back here figure out, well, if there's a fault on this main line here, there's no fuse to wait for, good, we'll trip without delay. But if the fault is on one of the far sides of these two fuses, we can wait. And now we can sort this out. We have pushed the protection out even past fuses to speed it all up. What does this mean? It means that for many faults on distribution services, the line from Coconut Joe's substation over to your house or our factory, it means that for many of those faults, we're going to be tripping them in, we are, in 20 milliseconds instead of 1 second. And just think what that means to the quality of electric power and the reliability of service. Here's another fun one. This one, I got to tell you, I had my doubts about it. And boy, was I wrong. So what our guys want to do, they said, Ed, we want to put a fancy TV set on the front of a protective relay. And I said, why do you want to do that for? We can watch Netflix in a substation? So I said, no, it'll make it a lot easier, a human-machine interface. So they went ahead and did it, and boy, were they right. So this one went on the market, and boom, in about this many months, we sold 1,000 of them. Customers love it. They were really, really right about it. So now let's take a look at it was a great idea. Now I can't wait until we do this in more and more things. This makes a relay as easy to use as your iPhone. Now let's try that fault transmitter we were just talking about. Nobody had ever heard of fault transmitters before because we invented those. Everybody knew what the meters and relays were. They've been around for a long time. Just the digital ones are so much better. So look what happened here. The customers are saying, huh, what's a fault transmitter? Well, oh, I get it. And then look what happened. It took off because it was a good idea. Now, I wish every new idea we had was a good idea. But in order to have a good idea, you have to have 100 ideas, right? And you have to go through a process of testing. But there's this delay because people have to learn. Selling is teaching. I love to be sold to by sales folks who are teaching me something about how my life can be better if I own this or avail of that service. Creativity in our customers, I like this, is that our customers express their needs in terms of their experience. So many businesses would think, okay, I'm just going to go out and survey my customers and do what they say. Where's the creativity in doing that? Isn't it a lot better if it's important to go out and listen to your customers, but then it's time to sit down and think, to turn off the music, turn off the television, remove yourself from distractions, close your eyes and think, how simply can I state what the customer is really trying to accomplish? How can I find even a better way of doing it than what he or she was envisioning in the first place? So I like to say, this is kind of rude in a way, it says, always listen to the customer and never do what he says. So I don't mean that, of course. What I mean is, whoa, it's kind of a shocking statement, right? And then once you get over the chuckle on that, you say, yeah, I am. I'm going to sit down and think and respect the customer for what he wants, of course, thank him for the information, and also see if you can figure out how to do something even better than he or she envisaged. Why does that work? Well, one of the things that you know is that there's 200 people in this room right now. Every one of us, God made us different. Now, for a couple of people in the room I know real well, I'm still trying to figure out why he made those guys so different. Okay? But we're different, and that's the grace of the human spirit. So what's so cool then is on top of that, we go to school. We learn different things. We have different kinds of experiences in life. And we can only express a need in terms of that idiom of experience and in terms of our psychological self. You agree? So now, when you tell me something, And if I'm any good at listening, and I try, I know I haven't done that well for the last 40 minutes, but that's just kind of the way things are set up this afternoon. Sorry. Okay? So we take your idiom of experience, and if I'm good at this, I'm going to combine it with mine. So it's a union of idioms of experience. Is that the plural? I think so. Of experience, not the intersection, not one or the other. Put them together. And when that happens, creative sparks fly. And where does creativity come from? Does it come from in the middle of 6 people at a conference table? No. If there's 6 people sharing experience and sharing ideas, the spark goes on in one or more individuals' brains. So collaboration in and unto itself is not what creates innovation. It might be what builds it and finally triggers it, but it's an individual thing that happens that we need to foster by listening to our customers. Okay, another fun example. This is the Republic of Georgia. And they had a pretty bad situation some years ago. The lights would go out once or twice a month, every month, throughout the year, every year. Now, I was just reading in the Dominican Republic that their costs of blackouts in Dominican Republic is $500 million a year. Okay, back to Georgia. So the question is could we help them out? So we did a study, go back to first principles, figure out what is really wrong with this power system, why does it go unstable, where do we need to measure things, how are we going to communicate things in a cyber-safe way, how are we going to make decisions fast enough to control that energy moving at the speed of light so as to quickly restore the balance between generation and load in order to maintain electric power for as many people as possible, and that's what we did. They've had 0 blackouts in the past 3 years. Now, hopefully it keeps working like that and nobody changes something, and we've got other ideas to make it even more robust going forward. So here we go. Am I running out of time? Oh, okay. Well, there you go. We're not going to see that. We're not going to see that. Here's some of your buddies who went to school at WSU. Here's SCADA systems. That's we're asking, what is life after SCADA? We know we need to control power systems better to make better use of the intermittent sources, and you're looking at the guys who are going to do it, who graduated from WSU. So in closing, creativity is one of our values, and it's certainly a value that ties in so well with learning the fundamentals at the university. And I like to remind myself of something I learned when one of our kids was in preschool, is that a hero is someone who solves a problem. Thank you for this opportunity to say hello to you this afternoon. And once again, it is such a pleasure to be part of the community of Washington State University and Pullman, Washington. We really appreciate the opportunity you've given me this afternoon to address you. Sure appreciate it.
Well, we appreciate everybody coming out and hearing Ed, and I know he had to run through his last few slides, but when we think about creativity, and for those of you who are students and you're thinking about maybe at some point you'd like to start a company, you've got a local expert here who can tell you what to do, what works and what doesn't work, and I think it's a terrific opportunity for us to all learn from somebody in our community who's done it so well. The other thing is Ed asked everybody to put their hands up that had been to SEL, and there was a lot that hadn't. I was talking to Noel, and what we're going to do is we're going to put an email out next week for anybody who has not been to SEL and wants a tour. what we're going to do is just work with SEL folks and organize that. So if you're interested, want to go over and see it and check it out, and you always wondered what was in those buildings, this will be a great opportunity to do that. So let's thank Ed one more time for a really intriguing talk. And Noel and I are talking in sign language over here. We have a reception afterwards with lots of things. Ed will be over there and some of our other SEL colleagues. And before we do that, can I ask everybody who works at SEL that's in the room, to interns, anything, stand up so we can recognize those folks. Go ahead. All right. Thank you all for being here with us. Very cool. We are dismissed, and go Cougs. Thank you.